Okay guys, here's the answer to the circle angle problem in the enriched module, in case you're curious how to do this one. So this is the information we have. So just a couple of mistakes people made were making assumptions that you can't really make if it doesn't tell you. Even if they are true, you just don't know they're true. So you never make an assumption unless it actually tells you, yes, that's the case. So all we know here is that this angle in here is 40 degrees. So we definitely know that. And we know we're trying to find this angle right here, x degrees. So we know that. We know this is the center of the circle, which is what this O is indicating. We are right at the center of the circle there. I don't know if it said that in the question, but it should have. So then, since that's the center of the circle, any line that goes from the center to the a point on the outside of the circle is going to be the same length, because that's going to be the radius of the circle. So this line right here will be the exact same length as this line and also this line, because they're all the radiuses of the circle. The radii? Okay. So they're all the same length. So that gives us a piece of information about this like triangle right here. It tells us that this triangle is an isosceles triangle because two of the sides are the same length. We don't know how long that side length is because it's not going from the center to the outside, so we don't know. But we do know that's an isosceles triangle. So therefore, we can conclude that, I don't know, let's see. We would know that this whole angle, not the 40, but the 40 and the other one, would be the same as this angle. We would know that. So that's something. And we'd also know, because there's another isosceles triangle in this diagram, and that's this triangle, this big guy right here. This big guy is an isosceles triangle because those two sides are the same length. And so this bottom guy, so that's an isosceles triangle. So we also know that whatever this angle is over here, let's say we called it Z, we know that angle is exactly the same as that angle. So those two angles are the same. So that's something else that we know. What else can we figure out? So I'm thinking, just knowing my geometry properties, I also know opposite angles are equal. So in this little section right here of angles that we have, like 4 different angles here, I know that the opposite angles are equal because when two lines intersect, the opposite angles are equal. That's just a geometric property. So if we called these angles maybe like A, so angle A, those two angles are exactly the same. So that's cool. So what other properties do I know? I know that angles inside of a triangle add up to, angles in a triangle add to 180. I know that. I feel like that might be helpful. So I'm thinking, like I'm kind of focusing on this triangle in here because it's got my unknown in it. And also this triangle in here because it's kind of like they share an angle. There's going to be some properties there. So another thing I'm thinking is, I don't know, let's see here. So I know that this top triangle here, x plus z plus a, is going to be equal to 180 degrees. And I also know this bottom triangle down here, 40 plus a plus, I don't know what this is here, but maybe I want to name this angle down here. I don't want to give it a new variable. I feel like we've got a lot of variables happening. So since I know that this bottom angle is the same as this angle over here, maybe I want to call this angle z plus 40, because it is, right? They have to be the same angle. So maybe I want to call it, you know what, I'm just going to write this over a bit. So maybe I want to write like this bottom triangle as A plus 40 plus Z plus 40 equal to 180. Maybe I want to do that. And then I can see I have A plus Z plus 80 is equal to 180. So that's something. If I move the 80 over, I can see I have A plus Z equals 100. So that's one equation that I've come up with. And here's another equation I've come up with. So I think since I'm proving that A plus Z is 100, so these guys add up to 100 degrees, I think now kind of showing, I don't know if that's enough proof, but that X has to be equal to 80 degrees, because I already know A plus Z is 100. So over here, A plus Z, that's got to be worth 100 degrees as well. It's the same variables. So maybe not, I don't know the values of A and Z right now. Maybe I do, but I don't need to. So I know that, well, if these things add up to 100 degrees, then this guy right here must be 80, because this whole thing has to add to 180. So if I know the combination of these two are 100, then this guy must be 80. So that's one way to find it out. But yeah, there's probably lots of different ways. But yeah, that one makes the most sense. Another way of kind of wording it is, I know these two triangles, like this one and this one, obviously add up to 180, like all triangles. And since these two are the same angle, if I kind of ignore them, then I know that like this angle plus this angle, so like for example, X plus Z has to be equal to this angle of 40 plus this angle of Z plus 40. So those have to be equal. So 40 plus Z plus 40 have to be equal to each other, because I know that both triangles would add to 180. And I know since the A's are the same, they're just going to cancel out. So I know that like the sum of these two have to be equal to the sum of these two angles. So I could do it that way. So then if I kind of like try to isolate X in this formula, I would have X equals 40 plus Z plus 40 minus Z, if I'm kind of subtracting Z from both sides. So then I have X is equal to, well, the Z minus Z, like the Z's are going to cancel out, and 40 and 40 is 80. So it's like another way to kind of look at it, same kind of thing. But basically, it turns out that X is equal to 80. And I know some people had some trouble with this because but I know some people had trouble with this and still got 80 as the correct answer. But you may have had an incorrect solution method. So it's not okay to assume an angle is an equilateral, to assume one of these triangles is equilateral if it doesn't say that it is, unless you've proved it using some kind of geometric properties like how we use the radius or whatever other things you can use. But if you prove it's equilateral, cool. But you don't want to say, oh, it looks like it is, or it looks like this takes up about a fifth of the triangle. Like, no, you don't want to start assuming things based on how they look. You want to have some kind of, for sure, geometric properties that kind of prove it. Okay, so that's just an explanation of how you could solve the circle angle problem.